In this video, I want to talk to you about exponential growth in a table form. We've already seen that the equation is y equals a times b raised to the x, where again, x is our exponent and it's our variable. We've seen that the graphs kind of take a shape where they start flat and then they turn sharply. I'd like to show you how the tables look. Let's take a look at a very specific one. Let's do 5 times 2 raised to the x power. So in this table, what we would find is our x values, we would find our y values, and if I just gave us some values to work off of, we could work through this. So the first one is 0. Plug in a 0, 2 to the 0 is 1, 1 times 5 is 5. The next one, plug in a 1, 2 to the first power is 2, times 5 is 10. The next one, plug in a 2, 2 squared is 4, times 5 is 20. For the next one, plug in a 3, 2 to the third power is 8, 8 times 5 is 40. And for the last one, plug in a 4, 2 to the fourth power is 16, 16 times 5 is 80. So here's an example of an exponential table. What we're looking for in an exponential table is a common first difference over here. Let me switch colors real quick. A common first difference over here. So yes plus 1, yes plus 1, yes plus 1, yes plus 1. We can see that. But over here, we're not looking for a common first difference. That would be linear, right? Up 5, up 10, up 20, up 40. That doesn't work. Not a common second difference. That would be quadratic. We're looking for what we call a multiplier or a common ratio. So take the second number and divide it by the first. 10 divided by 5, that's 2. 20 divided by 10, that's 2. 40 divided by 20, that's 2. And 80 divided by 40, that's 2. So what we can see here is that each time we move in a y value, we double. Times 2 gets you 10, times 2 gets you 20, times 2 gets you 40, times 2 gets you 80. The exponential growth tables have this characteristic. A common first difference in the x column and a common ratio or multiplier in the y column.